often an idea is just an idea until it's written down and somebody actually tries to make it.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. All right, so I am here today with Jesper Sørenson, and you are in Europe, right? What part of Europe are you in?
I'm placed in Denmark.
Okay, yeah. Cool. Sometimes the Scandinavian countries all run together for me. So Denmark, and you work with Steen at GPower.
Right? Yes.
Yeah, and you're also part of GCentral in the GIDEA exchange.
That's true. I am part of the board of directors for GCentral.
Oh, okay.
And
I didn't realize you were that high up. I thought you were just like a volunteer, but you're board of directors. That's great.
I volunteered for about a year, and then when I think when Francois stepped out of the board of directors, I joined in. And shortly after that, Christian Butcher and Enrique joined in as well. Enrique Noe. And regarding the GIDEA exchange, I worked for that for about a year, where I was and still am the secretary and general team lead on that project.
So can you tell our listeners, I mean, I've had Chris Cellino on, and it'll probably come out before this podcast hasn't come out yet as we're recording this, but what is GCentral and what is the GIDEA exchange? Maybe just a quick overview.
Yeah, so let's start with GCentral. We're a non-profit organization, and I'm almost certain that Chris will be talking a lot about this in his podcast episode. But we're a non-profit organization that tries to make the LabVIEW community the best version of itself. That's our mission statement. And one of the things that we have seen is that all the open source ideas that we have for how to put it, that can improve LabVIEW and can be implemented in LabVIEW code. We needed some idea exchange for that part. So we wanted to create somewhere where you could post your idea and give or get some feedback on it. And the initial part or the initial way it was created was very how to put it. It was quite closed, where it was only the GIDEA exchange committee that was actually discussing it and taking questions, and then opening it for funding when we had all the parts we needed. And that turned out to be quite hard to actually gather funding for ideas in the community. So we would set up a description of an idea that came from the presenter of the idea, and then we would basically ask questions of how to do it, and how they thought it would be implemented, and what they thought it would cost or take in time to do it. And often an idea is just an idea until it's written down and somebody actually tries to make it. So we could also see in the process that it took the process did not scale if we had 1,000 ideas the way we had it at that point. So we reached out to NI, and now we have a forum in the NI forum where you can post your ideas. So basically, it's sort of like the LabVIEW idea exchange, but the requirement is that it has to be open source, whatever you provide there. It has to be community driven. And we use it to gather the idea about creating a new toolkit, for instance, for LabVIEW could go through that idea exchange and still be part of the community. maybe the presenter of the idea doesn't want to build the idea, but would like to have the toolkit at some point. And one of the ideas that, or one of the solutions we came up with was that we could, from GCentral side, pay developers to build a toolkit if it had enough funding. That was the original idea. And that was before we added the NI forum. After the NI forum, we've sort of dialed down the financial part because finding funding for open source ideas is not just hard for LabVIEW, it's hard for everyone. So it's also a problem in the Python side. So that's not only specific to our community.
Yeah, definitely getting people to support open source stuff is tricky and difficult. I feel like you have to hit that 1 in a million use case where it's like super common and everybody uses it, and then maybe. And even then, like, especially if you release it for free, then people don't value it. I think it's one of those things. So
exactly.
Did you know that the LabVIEW experiment has a Patreon? All memberships include access to a private Discord server where you'll be able to chat with other fans. Benefits to membership include behind-the-scenes content and sneak peeks at new episodes, as well as opportunities to chat and even code with Sam. To learn more, check out our website, www.thelabviewexperiment.com. It's your contributions that keep our experiment going. Thanks.
It's quite hard, and there's one thing is to create the toolkit, but also the support afterwards. There's several incidents in the web space. If you look at what's commonly known on the internet as the left pad incident, that actually broke the internet for a couple of days, where there was a JavaScript library that actually padded the input fields, I believe, with so it was left aligned or something like that. And there was a single developer who decided to take it off the Node package manager, I believe.
Yep.
Or their package repository, and suddenly both Facebook, Instagram, and I think Google Plus at the time broke down because they were all heavily using this in all of their forms. So it is that's the downside of open source, is that if somebody decides to yank the chain on a project, that's actually that can disappear for you. So stuff to be aware of.
I think part of the problem was they weren't actually pulling that code into their code base, but they were pulling it down when they were building it or something, right? So when it disappeared, it was just gone. Versus if they had like forked a copy of it, then they would at least have it, even if it's no longer being maintained.
Yep. But also one of the things to consider is maybe to give a little bit back, either in it doesn't have to. It would of course be nice if we could all monetize free software in a way, shape, or form. But on the other hand, maybe provide a review or provide feedback in the form of new ideas would also help. And that's sort of the idea behind the GID exchange, is to create the forum and try and get a community-driven project. For instance, starting off with an idea that says we would like to have a awesome toolkit that scripts a VI based on the Python function would be quite cool. It's also quite hard to do. At least from my point of view. In that case, there's maybe it's easier to look into some to reduce the scope of the task, and then in that regard make it less problematic to build.
Yeah, that's interesting.
But also, if you open the idea and show it on the forum, then we can actually give people can give their inputs to it. Maybe we could just solve all the hurdles that is shown before actually starting to build any code. So we're just discussing an idea on a forum. That's sort of how Minecraft came around, I believe, where Marcus Notch Pearson presented, or he actually sold alpha copies of his project until he had enough to supply himself with rent.
Yeah, I think the forum is also a good thing because it stops us from reinventing ideas and ending up with like 4 copies of the same thing. If we can all get together and come up with one thing that meets everybody's use case, then sometimes that's better. We only have one thing to maintain. I know I was recently working on some stuff for like refactoring classes, and I showed it to somebody and they're like, "Oh, doesn't the Goop toolkit already do that?" And I was like, "Oh, like maybe I should check that first," but I don't use the Goop toolkit, so I didn't know. And so, yeah, some of that wasted effort is kind of a shame that we do that.
But we also have a tendency, at least sometimes in the community, not always, but sometimes a tendency that we distrust anything that's not built here, because then we don't know how it works. Not in all cases, but some places that we go, at least customer side, it seems to be that they've built their own system and they know how that works, but they don't want to. For instance, they built their own test sequence and they know how that works, but they don't want to integrate Teststand that actually solves more problems than it creates.
Yeah, I think there is probably some cause to be a little wary. If somebody else wrote the code, like you never really know. Does it have like how well supported is it? Does it have bugs? It kind of brings up that whole idea of like, should you really have dependencies at all? And it's a trade-off, right? Because on one hand, by having all these dependencies, you're not reinventing the wheel, and that's great. On the other hand, every time you bring that dependency into your project, you're importing that code, and now you have to maintain that code. And if they have a bug and they don't support it very well, that's a problem.
Yeah. And also, one of the other things when you take in external code is, at least from my point of view, you should build unit tests on the functions that you actually use. So you know that if they change behavior compared to what you actually expect, then you know how to roll back. You'd capture it in an earlier stage than you would at production level or when you start the build. So you can test whether you're running a new, better version of the package or if something changes in that direction.
So just yesterday, released an episode with Brian. I don't know if you got a chance to listen to that, but
I listened to that already.
Yeah. So he talked about that. They had some kind of hashing function or something. He had written a unit test for it. When they upgraded it, it broke, and I found a bug. So that's interesting. I feel like definitely if you're going to make some framework, some third-party framework or something, the core of your project, I think that's a very useful strategy. I think it probably doesn't pay off as well if it's some periphery thing where you're using like 1 or 2 functions, like, maybe who cares, but it depends, like everything.
Yeah.
But you mentioned the different, coming up with multiple different versions of stuff and like people, the not invented here thing. I wonder if part of that is also ego a little bit too.
Could be.
And I wonder too, a lot of it seems like in the LabVIEW community, probably in all communities, a lot of the tools that are out there are written by consultants. And I admit to being guilty of this. And sometimes like there might be a tool out there, but A, you want something slightly different, but also B, like if you're a consultant, like saying, hey, I have this tool and it does X is it has a little more cachet than saying, hey, let's use this tool over here that somebody else wrote. There definitely is a little bit of that. I mean, again, I think that comes back to like, what exactly are you trying to do? How closely does the library that exists do what you want to do or not? And the other thing too, in that I think we're missing out when we do that is improving the existing library. So, okay, so-and-so has a library that does X, and I want to add this one tiny feature. Instead of rewriting the whole thing, maybe I could go to them and talk to them and put in a feature request or even do a pull request and say, hey, here, I wrote the code to do X for my project. Here, maybe you want to use that.
Well, that's actually one of the things we have in the GID exchanges. If we can see something is clearly, let's say, for instance, you want to add something to parse JSON. Maybe it would make more sense to connect you to James Powell and use his JSON text library. Just add a feature to that one. So that's one of the ways we try to upgrade ideas is not to avoid building and to spread the waters on users and so on. And then is that steer them towards the existing packages that might have 95% of all the other stuff that you need.
Yeah, I feel like there's also this reticence in the LabVIEW community to like fork stuff and then modify it. I definitely catch myself not doing that as like, if it does 90% what you need and maybe you can't convince them to do that or whatever, you just fork it and make your own copy and edit it and use that. And I feel like people just, I don't know if they're not aware of that workflow or just don't trust themselves or whatever, but I find that can be very useful sometimes.
That can be inheriting a puppy, right? Then you sort of have all the problems as well with the new version that you built yourself. At least keeping it up to date.
Yeah, the keeping it up to date part's a problem. My blog is written in Ghost, and I took one of their themes and like modified it. But then every time they update their theme, I have to go pull down the changes and compare it with mine and make sure it all works. And so that's kind of a bit of a pain, but it's worth it. It works. But so you had mentioned Python earlier, so I'm curious, what are you using Python for, and how do you see it interacting with LabVIEW?
Basically, I use Python for all the small hacks that I just need to get done, where use, for instance, flipping pages in a PDF file or something like where there's no native LabVIEW stuff, and I need to interact with, for instance, my wife was making a farm show at some point, and they needed to put a set of plaques with the name of horses on and all the info of the horse on top of or in next to every horse in the show itself. It was about 150, so I thought I didn't want to do that by hand, so I decided to scour the PyPI package index to check for something that could write either a PDF or maybe a PowerPoint, because it would be a slide per page, because we had all the data in an Excel file, so I could read that from Python, and then wanted to use just PowerPoint because it was really, really simple and it was easy to print.
Yeah.
So basically using code to fix my problem there was some of the latest things I've built in Python. But in the last Tuesday this week, I was at the Reconnect event, which is NI Days in Europe. And here I presented about installing Python on your PC through the NI Package Manager. So it was a rerun of my presentation from GLA Summit 21.
Now, is there an NIPM package for Python, or you took the Python installer and packaged it yourself into an NIPM package?
Packaged it myself.
Okay.
In just using LabVIEW. So basically a LabVIEW project and a build specification in LabVIEW.
Are you guys using NIPM a lot?
For some distribution and for some customers, yes. Others are more conservative, but there's also some issues with the NI Package Manager. Not to complain, but maybe one of the issues is that it has to be updated always. Otherwise, if you in some part of your chain update your package manager, then it will break.
Yes, I noticed that. I complained about that. Yep.
So if we could get rid of that part and downgrading packages, and add downgrading of packages, that would make it a fantastic tool. The main reason why I did all of this for installing Python was in LabVIEW 21, the installation of packages of LabVIEW and using it with Python was sort of an Indiana Jones adventure, where you would find any kind of falling rock that you would run away from for any amount of time. So basically, I put together the presentation, and it resulted in quite a lot of interesting learnings, both for LabVIEW and Teststand, where you could basically it goes over presenting about first installing the interpreter itself, and then downloading all the packages if you're doing it on a system that is not connected to the internet, but you're allowed to move a NI package through a repo or something similar, maybe a USB stick, and then how to solve that issue of actually packaging all your Python packages into a LabVIEW package.
I was about to ask, what do you do with all the Python packages? Because packaging the Python exe is one thing, but then you got all the pip install stuff that you would.
That's the key. The keyword is pip download.
So you type in download, and then it just downloads it, and then and then when you pip install on the machine that doesn't have it, do you just somehow point it to that path and it installs it, as opposed to
there's a no index keyword and then a -d. You can specify the folder for where it should look for all the packages that you need.
Oh, cool. See, yeah. I didn't know that. Learn new things. I figured there had to be some way to do that, but
yep, it took a while in 21, and I had to refresh all of it just for this Tuesday. So that's why it was one of the things where there's at least the documentation in LabVIEW in 21 was really lacking. Just the small thing about finding a graph that showed you what are the compatible versions. You had to.
They're very specific about what version of Python it's allowed to use, right?
Yeah, exactly. And it's especially about bitness. If you're running in general, I believe in GPower we run LabVIEW 32-bit.
Oh, you guys are 32. Is that for backwards compatibility with older stuff? Because I've finally given over to 64-bit. It took me a while, but
I think we just tried. Many of our customers haven't moved that far ahead and are not using 64-bit, so we haven't seen the requirement yet. Even though we do have a few customers that are using both, and that sometimes gives some interesting problems, like when in LabVIEW 21 before they actually made the service pack 1, there was an issue with installing packages that were third-party licensed with the T-Plat platform, but it would invalidate your license file.
Oh.
So when you installed this, when you registered the add-on for LabVIEW, it would invalidate your license file. So you should, if you're running both 32 and 64-bit, you should upgrade to Service Pack 1. Otherwise, you'll end in some sort of unrecoverable problem.
That's interesting. Yeah, I didn't know that. There was also something for a while with the 64-bit where it wasn't supporting RT and maybe FPGA, and I thought they maybe fixed the RT part, but the FPGA you still need 32-bit, or I don't really remember.
Not entirely sure. I haven't followed up on that, but 32-bit seems to be working still. So at least until now, where they have 23Q3, right? That's only 64-bit. So I haven't moved there yet. So.
Are you guys mostly using Windows? Are you using Linux at all? Have you guys dipped your toes in that?
We are primarily a Windows shop.
Okay.
So.
Because I've been talking to several people who've been moving to Linux a bit lately, and I'm definitely very interested and excited about that. So.
Yeah.
I'm not a huge Windows fan, so.
Well,
if it works, I use it, but. Yeah.
I would say, from my point of view, I've not learned or run into something that was so hard that I had to use Linux on Windows at least. So it's just sort of maybe it's a Stockholm syndrome. I don't know. I just learned to live with it.
Yeah, for me, I started building my own computers, and when you build your own computer, and then you have to fork out $200 for a Windows license, you're like, I don't want to do that, and then you end up with Linux, and then I learned how to do all this bash scripting and stuff. And also the big thing for me was managing servers. So when I started at Westinghouse, they had a Bugzilla and SVN server, and then I quit, and I was like, oh crap, I don't have any of that, and I have to set up myself. And so then I had to learn Linux to do that. And then the big push lately is I really don't understand PowerShell. I've tried. I don't know. Maybe I'm just thick or whatever. I read a book and I was like, this sounds horrible. Why would I want to learn this? And I already know how to write Bash scripts. So the good news is if you install Git Bash on Windows, you can run Bash scripts in Windows all day. And now Windows has the WSL thing that will also let you run Bash scripts. So like, I don't know, there seems to be less need for me to try to learn PowerShell.
Yeah, it would also be if I had to script something, I would go for Python. So that's my way of solving those issues.
I've kind of went from scripting in Bash to doing more Python stuff when I need some more complicated stuff. It was funny you mentioned the flipping PDFs. That was like the first Python script that I ran because I went to this conference and the guy handed some flyers out or like a workbook, but it was double-sided, and I wanted to scan it in. And you scan it in, but you can only scan, like I had a document scanner, but just scan one side at a time. So you scan it in and then you flip it around, you scan the other side, but now you've got these two things and you have to like interleave them. Yeah. So I wrote a little script that like open two PDFs and interleave all the pages. Because that's surprisingly hard to do otherwise. And it's surprisingly easy in Python. It was like a 10-line script or something. So yeah.
Also, my wife had she's also an accountant. So she had a problem at some point. She gotten all the receipts from a customer that was a checkout from their system in a zip file. And she needed to put them by date. They had to be extracted into folders. But the way it was structured in the zip file was actually quite simple, and in Python you can open a zip file in memory, and then you don't have to then you don't corrupt the data when you put it into if you just extracted it, it would be in the wrong folders and it would be in the wrong order. So here you could extract them all and rename them with the right date.
Interesting.
So that was actually also one way of solving the problems. I've looked for the same features in, for instance, LabVIEW. It has zip compatibilities, but it doesn't have open unzip in memory and just interact with a zip file without.
So, if anybody out there is listening and is interested in learning Python, there's a book called Automate the Boring Stuff with Python, and the guy even has a website, and it covers a lot of those type of little tasks, and that's a really good way to try to learn a new language because you do the examples, okay, whatever, but like you need something that A is somewhat challenges you, and B that like actually does something useful, and then it becomes a lot easier to try to figure those things out. So speaking of Python, what do you like about Python versus LabVIEW? Like aside from like, okay, some things are just easier to do and one or the other, like why is there a reason you would choose one over the other besides that?
It's sort of if it's a one-off. I've started to write more LabVIEW scripts for one-offs as well. Just writing a VI that you could, to me at least, a script it would be a VI that you can just press the run button in LabVIEW and it does something, and it does it consistently enough that that you could reuse it. I've started to use more of those if I need to process multiple files or similar. Mostly because I could also write it in Python, but many of my colleagues don't use Python, so it's more convenient to put in LabVIEW as something we're sharing. And additionally, I would also probably just one thing to consider is also the amount of obstacles that you run into if you go from a blank PC until you have LabVIEW.
Yes, that was going to be my point. Yeah, one of my points.
Versus a blank PC until you have Python. It's a 40 megabyte download, and then you're ready to go.
Well, especially if you use Linux like I do, it's already there. And trying to install LabVIEW on Linux is kind of a pain. So, and then if you want to like, yeah, and like LabVIEW, if you want to make something that's portable, then you've got to build it into an executable and make it callable from the command line, perhaps. And then, right, like with the Python script, you just Python-m, whatever it is, pass all your parameters, and it's done, and it runs. And yeah,
and there also sometimes if you have a LabVIEW application, we did that at a customer side at some point, where they the application itself needed to do some extra stuff, but we didn't want to handle, for instance, XML files, large XML files in LabVIEW, because it wasn't built correctly at that point. I mean, you could probably do it, but it would be quite a hassle. Whereas the built-in XML tree in Python is quite intuitive to work with, and also quite easy to work with. So writing
dictionary, is that it?
Which one?
Does it just basically turn the file into a big dictionary?
Well, there's the XML tree structure. I think there's a specific subclass for XML that actually has. I think it's called eTree.
Because I've done JSON stuff in Python, and it just basically opens it up as like a big dictionary. So
this one creates a custom class, but the thing is that it will, how is it? You can index by name, but you can also do XPath searches. So it's quite powerful, and it can write. Basically, it also writes the file back to disk when you're done.
Awesome.
And it can also do all the indenting if you have a very strict way of setting up your indents. So basically, this handled all our XML structure, all the additional stuff we needed to do. In hindsight, it would probably have taken half the time longer, 1.5 times longer to build it in LabVIEW. So it could be done, but on the other hand, it would be taking longer at that point. Cool. It was also in LabVIEW 2017, so that doesn't make it easier.
Yeah, older versions of LabVIEW, yeah, it's funny, right? When they were new, it was like, oh, this is great. And now you look at it 5 years later, and you're like, this is a little slow and clunky, and my favorite editor feature is no longer there, and things like that. It's very interesting. I'm kind of curious about like cross-pollination between LabVIEW and Python. So like, are there things that you learned in LabVIEW or Python that like applied to the other one? Like you're like, by solving a problem in one, you're like, oh, I learned this neat trick, and now. Because for me, like sets and maps, right? We didn't have them in LabVIEW for the longest time, and I learned about them in Python, and now I find myself using them in LabVIEW a lot to solve problems. Do you find things like that?
Well, some of the things that I have brought from LabVIEW to Python is maybe the code. No, I wouldn't say code style, but having the care about your code enough to make sure that you're naming the variables. Don't just use A and B and output, but actually taking the time to name stuff and making sure that you have written some documentation for your functions and validate your input. A thing that we get for free in LabVIEW, or at least almost for free. The type propagation, because in Python it's only hinting unless you're actually working with the MyPy interpreter. So a lot of those things I've moved over to LabVIEW or to Python from LabVIEW, and that definitely makes my Python code look more rigid, and it makes it probably less Pythonic. But on the other hand, I quite like it. It fits my brain when it comes to that part. One of the other things that I brought from Python to LabVIEW is probably the considering generators, because that's a feature I would like to see in LabVIEW, because that's one of the big strong selling points of Python, is that you can have a generator that actually lazy loads your file, so you can have an infinitely large file that you're just reading line by line, and it will only load the next line and then wait for somebody to call up the tree and ask for the next line of the file.
Yeah. So for those who aren't familiar, basically generator is kind of like lazy iteration, right? You have an array of things, but it doesn't calculate them until it actually needs them, as opposed to calculating them all and loading the whole array into memory. Does that about sum it up?
Yeah, exactly.
So I want to make a couple points. I want to get back to the generators thing, but I find it's easier for me to write clean code in Python. Not necessarily that it's easier, but it takes less effort. Maybe that's just me, but like it's super obvious. Like, okay, I need a line here, I need a line there. Good names here, good names there. LabVIEW, I find there's a lot of fiddling and like moving wires to get them just right, and I feel like in LabVIEW we kind of obsess, some of us, over like, oh, these two terminals have to be exactly lined up and stuff, and it's like I don't know. I find I get frustrated with that. I find like the effort that I put in versus the payoff is generally not there. And I may be an outlier, but I've gotten in the habit of often just clicking clean up block diagram, which I know is a horrible thing. And if I have a small VI and it's like, a class method that's got 3 nodes on it, I just click that and I don't even look at it. I just close it. I'm like, okay, I'm done. Because otherwise, like, even if there's only like a handful of nodes on the block diagram, you can spend a lot of time rearranging wires. And I always let them like, what's the value trade-off there? I don't know if you noticed that or not.
Well, basically, I do notice that we also do that a lot at GPower. But in the good way. I think one of the things that we have is it sort of gives you the mental break. That you think about all the ways you've wired up all the stuff, and maybe how it would clump together. How would the interpreter look at this code, which is a bit different point of view than it would be to actually write the code. Because when you write the code, you need sort of the room to put in all the structures, and you need all the room for the nodes, and where does your error wire go, and what needs to be what errors do you react to, what errors do you ignore, and so on, so on, so on. So in that case, when you sit down and you look at the block diagram, I usually start from the end and then sort of fit it all the way backwards, and sort of rearrange it and make it look really neat, because it sort of takes the time out to think about these parts. What's the performance here? Have I forgotten to put in a shift register, or should I use a feedback node here? Or are there other, could I rearrange the inputs for this OR function to make my diagram look a bit cleaner? In some cases, you could reduce the number of wire crossings to make it much cleaner, or should this be a sub function or a sub VI? That's
in my discussion with Darren. He mentioned that one of the, I think he said the most underrated feature in LabVIEW was or one of the features he liked was the remove space, which I think makes that whole process a little bit easier, because you can drop stuff and you can spread it out. And that leaves you room to drop new stuff if you think, oh, I forgot I need to add a build array here or whatever. And then you can always shrink it back down later. And I find that definitely helps. I do know Steen is very particular about how he likes his code, or at least that's the impression that he gives off. So
there's not to he'll probably listen to this, so I need to weigh my words here. But I would say he's been a big inspiration on how to actually make clean code and make code look really awesome. Even though we are continuously challenged on how our code looks, but I think that's actually it's a strength to see that somebody cares that much about it. Because if we deliver something that is that just looks subpar, is not the GPower way. It's we really, that's also why I presented at GDevCon about how to create icons, because it is such a small thing about your VI, but it just says so much when it comes to something that is in an API, that you can actually see all the functions just from the icon itself. So for us, it's some of the built-in DNA that we really look for in developers, is that people who really care about their code. It's not just an 8 to 4 job. It's something to be proud of by the end of the day.
Yeah, no, I mean that's good. You guys have some values there, and you stick with them, and it's obvious he's built a culture around that. I will give him some credit. The one thing he's done that I like, that I hear him talk about, is the way you guys do air handling and bubble stuff up. And I have to say I don't do that, but I like the idea and I understand the logic behind it. And I think it's pretty sound, and I think that's a good way to do things. I do think there's a difference between writing toolkit code that you're going to hand off to somebody and they're going to see too, and then like a lot of the stuff I write, like the only person who sees the code is me, and I hand the customer a built executable, so my stuff doesn't necessarily need to be as polished, I would say. Like, the only person who I'm handing it off to is whoever the next guy to come in and inherit it is, and they're probably going to change a bunch of stuff anyway, because that's what always happens, right? Like, you inherit something, and even if it's well written, it's never the way you would do it, and you're always like tweaking it, and right. So I have to admit, I'm probably one of those guys who I do the text icon, and I usually just like go, unless if I'm posting stuff on like VIPM or something where I'm expecting other people to use it, that's where I think it's really worth the effort to put that level of polish on it, because there's no connection between you and whoever's using it, right? Like, even in my job, like when I work on a project, often when I leave, if the next guy comes in, I'm still around. He can call me up, we can talk, and they can pay me a few hours, and I'll come in and show them what's going on, and like there's something there. But with like VIPM, there's like lots of people using your code, and there's zero connection between you and them. And so therefore, all you really have is that level of polish in the API documentation and the icons and stuff to kind of tell them what's going on.
Yeah.
Yeah.
There's just maybe one question. Have you ever had a former project of yours that you came back to half a year later and thought, whoever wrote this code?
Every single one.
So that's sort of what we try to avoid. And there's sometimes when the heat is on and you really need to get some stuff done, it's, if you keep in mind that fixing it now versus leaving it for 2 days and then fixing it, then that's sort of just more helpful, because you have all of it in your mind at the point. You know exactly how it works. You don't have to relearn it. And that's where this cleanup actually, at least in my opinion, helps a lot.
Well, I think there's a distinction too, in the sense of like the type of work you're doing, because I do a lot of R&D stuff where things change constantly, and I'm just trying to get a proof of concept out. And the quicker I can get the proof of concept out, the quicker I can figure out if I'm on the right path or not. As opposed to like, you've got, I don't know if you guys, I'm imagining you guys probably have more of a like fixed price big contracts where like the requirements are clearly defined and you guys are just writing stuff. Is that more, or do you guys do more of like an agile style, or a bit of both? Or
I think ours is more agile,
okay.
sort of also with a very fluent requirements from time to time. So and reinventing the wheel, if we, or not the wheel, but all the other projects that we have to. Yeah. So basically, what we've done is internally we have a huge set of toolkits that at some point we are planning to make a release of to the VIPM or wherever we can release them to.
I will challenge Dean a little bit. I've heard him say that many times over the years, and it's been many years. So it's
sort of like the nuclear countdown clock. It's closer than ever. Okay. So I think in general we are really close at for this part, and it'll definitely be interesting when it hits the community, because we've had the sets and maps. Actually, we've had a solution with dictionary since LabVIEW 2017, I believe, that did some of the work, which was quite useful. And all of these projects are mainly to make us faster, and that's where we have some really skilled colleagues who build internal tools and templates and all these other projects that makes customer projects easier. At some point, I think we had a marketing poster that said we were 80% done when we started. but it meant that we didn't have to reinvent all the frameworks or build a new producer consumer in order to get some stuff done. We have quite good active framework. We have projects for messaging. We have tools for building VI packages, which is probably our most secret sauce is VI packages. It's just building stuff that you can install and upgrade, and compartmentalizing your code into tools, and then only a few VIs that bind the code together.
So you guys use VIPM for your internal reuse? Is that the main driver? Yeah, I'm a big fan of VIPM. I'm curious, do you guys have an internal reuse team that just works on building reuse stuff, or does all this stuff just naturally bubble up out of a project? You're like, hey, I'm writing this library for a project. I think this might be reusable. Then you throw it somewhere. Or how?
We have a Sten who spends almost all his time on these kind of projects, which is an absolute joy to come across a new project that he's built. For instance, fixing something in VI scripting that is really hard, or copying stuff, or copying a LVlib because you need to move some code to make a duplicate of an LVlib. It sounds trivial, but it is extremely complicated once you have to do it programmatically. If you have to do it on disk and you have to do it by just by a person, that's not the worst problem, because much of it is solved in LabVIEW, because the editor takes care of all the problems. But if you open the engine room and try to do it programmatically, you're opening Pandora's box of problems for yourself.
Yeah, scripting is interesting and very powerful, but also very hard for that very reason, because it's kind of like the idea of, like, I don't know if you've seen the example where the guy's trying to teach his kid programming, and he's like, okay, we're going to make peanut butter and jelly sandwich. Grab the peanut butter, put it on the bread. He makes the kid give him instructions, and he just takes a piece of bread, puts it on the table, and puts a jar of peanut butter on it. He's like, no, that's not what I meant. Open the lid, and right. And so scripting, the things that you can do easily in the editor are actually a lot of different steps in scripting, which is one of the reasons why I like Darren. It's always like, start with a known VI and delete things, or like do hard code as much as you can ahead of time in your template, and then just add or remove the handful of things you need instead of like starting from scratch.
Yeah,
it's really hard.
But there's also where one of the latest tools that we have, because we would like to use a given template on our new VIs. Mm-hmm. And we have a developer tool that actually can create a new actor for you. It can create a new class for you, and so on, so on, so on, from a given set of templates. So figuring out how to integrate that correctly with LabVIEW is not trivial, but it's something that we have now had for a couple of years, and it's really, really useful, I would say. Because it makes us, you don't start with a default icon. You start with something that's templated, where you need to put your glyphs and where you need to put your library icon. It has the NI library layer, so it doesn't. So if you put it into an LVlib, it doesn't kill off your icon immediately, at least.
When I worked at Westinghouse, I did a side project, and I wish I would have saved a copy of it somewhere, but I did not. But basically, I was working with a guy who didn't like updating the description and the icon and all that stuff. And so basically, I wrote a tool that instead of going to new VI, you could launch this tool, kind of like what you're saying, and you could say, here's a VI, here's the description, here's the name, and they would automatically open the icon editor and force you to edit it, and it wouldn't let you exit if it was blank or if you didn't use the default. And then I also expanded it and did stuff like, you could make a functional global variable, and you could give it, here's the enum, and here are the 5 things I want, and it would script it and put it in a library and just expose the method VIs to access the global variable and things like that. It was really nice, and I quite liked it, but unfortunately, when I left Westinghouse, it stayed there. So I don't think anybody's actually using it. The other downside to that was everything that was created with that tool matched the stuff, but there was nothing stopping anybody from going to new VI and creating a new VI and completely bypassing it anyway. So it didn't really achieve what I hoped to do. So
that's where I think, at least here in GPower, because we are so used to having all the tools, is that when you then get to a customer where you don't have the tools, you have to remind yourself, okay, how is it that we do all this? What are all the good things that we remove from by using the tools, such as forgetting to set the separated compile code and so on.
That makes dealing with legacy code quite challenging, actually, because especially like I'm going through this right now because I'm trying to write a set of refactoring tools for LabVIEW to make it easier. But the question is, what version of LabVIEW do I write them in? Right? Because if I write them in a really old version of LabVIEW, now I'm limiting myself in the editor and what I can actually do. But if I write them in a newer version, then they're not that applicable for actual refactoring because most of the refactoring happens in older versions of code. I mean, I have to admit, I don't do a lot with hardware, so I am much more on the, if I inherit old code, one of the first things I try to do is upgrade it to the newest version of LabVIEW if I can, and go from there. I don't know, you guys probably don't do that. Do you, like if a customer comes to you and they have something written in LabVIEW 2014, do you try to upgrade it to like something newer, or do you just say, we're going to use LabVIEW 2014 because that's what you're using and we'll just stay there?
Depends on the customer requirements.
Okay.
If the customer says that they only have license for LabVIEW 2014, then we just stay on 2014 and then we solve the problems from there.
Yeah, most of my customers don't have licenses. So they're hiring me because they don't know any LabVIEW, and somehow they got stuck with this LabVIEW program from way back when. So
yeah,
from that point of view, they don't care. The big issue is usually like hardware compatibility or something. You know, they're using some weird piece of hardware that, for whatever reason, is only supported in LabVIEW 20XX or whatever.
Yeah. I think we haven't moved it yet, but we are selling a product for expression parsing, and that's still being maintained in LabVIEW 2013, and then it's useful on all the later versions of LabVIEW. But the main development of that is in a very, very old LabVIEW version.
Yeah. Well, circling back to the GIDEA exchange stuff, I think one of the big things that stops people from contributing to open source, I think, is that right there. Because I know, like, I was using Karaya and I wanted to contribute to it, and I looked into it. And it's like, oh, you have to set up a virtual machine with LabVIEW 2014 and like install this old stuff. And it was just a pain to get that up and running and find the right versions and install the old versions of, you know, whatever other drivers you need. And so that in and of itself is a challenge. I wish that was something that LabVIEW could adopt from Python, right? Because Python, like, the interpreter cares what version you're using. The editor doesn't care at all, right? You can open code that was written for for Python 3.7 and 3.10 or 12, and the interpreter cares when it tries to run it, and it will say this function's been deprecated or whatever. But
yeah.
So, yeah.
That's also the, I guess, the crippling point of the NI package manager is that you have to run on the latest in order to install the latest LabVIEW, but in doing so you break backwards compatibility with whatever has been built.
Yeah.
So that's sort of a very sharp one-edged sword that only goes one direction.
Yeah. So I have an example I can explain that because it happened to me. So I was doing a project. We were in LabVIEW 2020, and I was building packages using NI Package Manager, and they were installing them in NI Package Manager. Everything's fine. We decided to upgrade to LabVIEW 2022, right? So I upgraded my machine to LabVIEW 2022, created a new virtual machine. It downloaded the latest NI Package Manager, NI Package Manager 2022. Well, their machine still had NI Package Manager 2020. And they can install the new runtime engine, that's fine. But when they go to install my package, because I built it in NIPM 2022, now all of a sudden it won't install on their machine and they have to go upgrade NI Package Manager. It's just kind of a pain.
Yeah.
Whereas before, all they had to do is just install the package and everybody's happy. And now they get this message, I can't open your package. I don't know what to do, blah, blah, blah. And it's just kind of, yeah, it's difficult. And
absolutely. And of course, it's a nice product. And they don't have any competitors on that market right now, but it would probably have, at least you could argue that having the solution for distributing the packages, just the copying and executing files, if that was a separate product of the package manager and you didn't build the LabVIEW side and Teststand and whatever install this system on top of that as an extra. But then you would have to install 2 products in order to install your product. That wouldn't be a useful situation either. So I haven't found the right solution for this. I'm just arguing that that there's some room for improvement here.
It's a shame actually, because we had VIPM, and we still have it, and it works. Like VIPM is leagues above NIPM. Like I don't know how they didn't like look at that and like, downgrading. Like why would you not think that people would want to downgrade packages and like certain things like that? And just the user interface seems very clunky. Do you notice customers pushing back when you're like, oh, we want to install this executable that we gave you? Oh, but you got to install this package manager first and the runtime engine and all that. Like versus like Python, it's just like, here's a script, run pip install requirements, and then run our script, and it all works.
Well, often what I see at customers is, or not to pick on anyone in particular, but the part about requirements is sort of they're not really sharing their Python code, whereas in LabVIEW we have gotten used to the package part, and you usually have the VIPM set up with a VIPC or similar that sets up the correct environment for you in LabVIEW. But looking at Python, then it usually somebody has 3 versions of Python, and they can't really remember which one it's running in. So that's the sort of the other side of the coin, is that it's so easy to create a new Python, going for instance from Python to having Python 3.9, Python 3.10, and Python 3.11 on your machine, and no rules for aligning. That we only in the company we use. Not at GPower, but let's say at a fictitious company, we use version 3.10 because it's stable now and it's running. So you can't have any older interpreters on your PC.
Wow.
That would solve some of the problems, but nothing's really preventing people from running anything from 2.7 to 3.12 that came out last week.
Well, what I've taken doing is just virtual environments everywhere, and that seems to work, although maybe that's a kludge or whatever. But
I think just getting people to write a requirements to text file as the first step in their process, whereas just writing the Py file that actually describes the functionality. So first of all, describing your environment versus just starting to code something is sort of the hard part.
Yeah, I don't know. I find, for me, I mean, I use PyCharm, so like every time I start a new project, I open up a new project, it sets up the virtual environment file and the requirements. It's very good. But I do think there is like that. There's like a hackerish thing that like sometimes I find myself like, I just need to write a simple Py script to do this one thing. It's not worth starting a whole project. I'll just run it on my main interpreter or whatever I have installed, and I don't. But also, too, there's some things in Python that, like, if you're not using functions that only came about in a certain version or that are deprecated, the same Python code should run in all the different versions, right? And I mean, again, this depends on your use case, right? If you're writing mission-critical software or something, then you really care. If you're just writing a script to concatenate a couple PDFs or to rearrange some files in a directory, like, for example, you're thinking about renaming this stuff in the zip file. That would probably run in almost any version of Python because it's just generic, plain vanilla Python. Yeah. And same thing in LabVIEW, right? If you're writing generic LabVIEW code that's just like a for loop and a shift register and blah, 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 those things have been around forever. So
the downside was actually we burned our hands on one of these at some point, because in the XML parsing example I created earlier, we had to shift from running Python 3.6 to running Python 3.9 because one of the developers included the indent function that was not available until 3.9. So we had to put in a requirement that that it would actually throw a runtime exception if the version was the version of Python executing it was less than 3.9.
Yeah.
So
it does open the door to some subtle bugs if you're not careful. So
yeah.
I think that a lot of that just depends on what are you doing, right? If you're just doing the quick and dirty scripting, and even in LabVIEW, right, it's the same thing, right? If you're just doing quick and dirty, like the difference between somebody who like has an oscilloscope card and just wants to capture a waveform versus somebody who's designing a complex test system, those are two very different use cases, right? And you can get away with, if you're just capturing data on an oscilloscope, you can probably get away without using get and without doing all the fancy stuff, and you can get away with an ugly block diagram and whatever, because it's the use case of like, who cares?
Yeah.
But then you build habits, and then you get into you design something more complicated, and it's like, oh, that's a problem.
Yeah, exactly. When you need to reuse it in some other context, then you run into the problem, or you pay for the lack of design that you already put into your other project. And if you forgot to do the documentation, then it might be hard to figure out why you haven't separated, for instance, the reading of the code, not of the code, but of the DAC card versus all the value process.
Yeah. That's probably one of those things where it's like proof of concept mode versus like production mode. And proof of concept mode, like people in Agile talk about doing a spike, right? You do a spike, you're doing a proof of concept to see if something works. You're going to throw that code away at the end, right? And people get upset about throwing away the code, but the product of what you're doing is not the code, right? It's the learning. It's like learning that, hey, this works and I can do it this way. And then you keep that learning, you throw the code away because the code's ugly, because you're just trying to see if it works. And then you go back and you write it, quote, the right way. I hate saying the right way, but big quotation.
I heard about a more extreme way of doing that, where you would start by writing a unit test and commit those. And then if you tried to commit and didn't pass the unit test, it would reset your Git repo to wherever you committed the unit tests.
I think it's test commit revert. Is that what they're?
Something like that, yeah.
Yeah.
That's extreme, but on the other hand, at the end you get really good at writing the same piece of code.
Yeah. No, I'm a big fan of test-driven development and unit testing, and I am actually a big fan of throwing stuff away, in the sense that oftentimes I'll write a unit test and I'll write the code to make it pass. If it doesn't pass right away, I'll spend like a tiny bit of time debugging. But after like 3 or 4 minutes, if I haven't made progress debugging, I'm like, okay, throw it away, try again. And like, there's something that's not very satisfying about like, I really want to know why it failed. But like at the same time, like if you're trying to make progress, it's probably easier to go back and start over and try a different approach, and like it works. And like, okay, yeah, I don't know why that code didn't work and this one did, but I know this one works. Let's move forward from here. So it's an interesting philosophy. But it is a huge change for a lot of people. People don't like that. People are resistant to that way of working, I think. People, like you said with the requirements thing, I think people just want to dive right into writing code. And I feel like that's a little bit of a mistake. Like, I appreciate the bias to action and actually solving problems and getting out there and trying things. But like having a little bit of structure first, I think is good.
And also,
write a test first. Okay.
Yeah, exactly. Because it's sort of the way the problem is seen is, if you look at the test itself, the test actually should bring you value immediately, because you'd know once the test passes, you can move on to the next problem. Of course, writing the first test is hard, and it usually ends up being a pseudo test. In some cases, maybe it's how to put it, it's a calculation that for some given values that it should give out some other values, and you need to put a sub BI in between these inputs and outputs. Yeah. And I believe I've seen you create just a sub BI from within your test case.
I dropped like a flat sequence, and I'm just like, this is going to be my sub VI. What needs to go in, what needs to come out, and turn that into a sub VI. And I find that actually really helps clarify my thinking a bit. It is slower and it is tedious, but the other big thing is writing tests when you find a bug, because I just found a bug in a piece of code yesterday. I just released a new package on VIPM, and I found this bug, and I knew exactly what the problem was, and I could have just immediately like changed a constant or whatever and fixed it. But I was like, hold on, Like, even if I just do that, when I'm done with that, I need to test that to make sure that it actually fixed it. And I'm like 100% sure it's going to fix it, but I still want to test it. So write the test first, watch the test fail. Okay, now go change it. And it just made the process feel a little bit more refined and a little bit more like, when I was done, I was super confident, like, yes, I've got this problem. And I'm confident that it's not going to come back because I got the unit test now and it's going to run every time I do my build or whatever. And so
I had a problem where I had to interface to a hardware device that was running on, I believe it was Modbus or serial communication, but it was a structured way of sending commands to the device, and it would receive some other data. And my approach to that was writing first the unit test for the failure mode. So if how I was supposed to react to a failure, and then for all the commands that it could send that you could send this device, I was supposed to simulate. I would write a single unit test that contained all the commands, and then when that failed, I would split that part out in a new unit test. So basically, if you're only supporting half of the commands that it could handle, then you would reduce or you know that you had one unit test that actually failed every time. If you implement a new command, then something needs to be tested, and this would be my way of fixing that. So this was quite an interesting project to work on.
Yeah, it sounds quite interesting.
But also one of the things that maybe it's a bit of a tangent, but one of the things here in GPower that we do monthly is we have this our own hackerspace where everybody can bring their own project. So, for instance, if you're trying to learn a new framework on your own time, or trying to get ready to take a CLA or whatever it might be, then we have set aside a period of time where you can come and have the input from all the other guys on how to work on a problem that you would like to work on. It could also be something at home that doesn't work, some sort of electronics that's broken or whatever it might be. But it's then it's after hours, and the company brings pizzas and Coke. So it's quite relaxed, and something that we definitely would suggest other companies to do because it brings a good culture.
Yeah, I quite like that idea. It's encouraging people to try new things and experiment and learn, and it's also sharing knowledge across, right? Because if you're doing something and it's doing database stuff and you know database stuff, and somebody else knows about database stuff, now all of a sudden you know what they know. So yeah, it's a really good idea. So we could continue this conversation for a long time, but my editor will get upset if we go too long. So we should probably wrap things up. Have any last minute thoughts or any last minute wisdom you want to impart with people with?
Well, if I could make one thing, if I could wish for one thing in LabVIEW, it would be the black auto formatter, but it should be
Yes.
scriptable, but in such a way that it would format it to my specification, of course. But in general, I think that's one of the things that we see in Python that it has over many other languages, is this tool that was written that enforces rules for the style in such a way that you don't disagree on. After you've run black, then everybody at least agrees that it follows the same standard, whether it's good or bad. So basically what the auto cleanup would be if it was actually working and did it collaboratively, or not collaboratively, what's the name of it?
Deterministically is one thing.
Yes,
right? Not deterministic,
exactly.
right? You run it, and one of the things with black is if the code is functionally the same and has the same variable names and everything, and you press and you run black on it, even if it's organized differently, it will end up in the same organization, right? Like it alphabetizes stuff and organizes, and so yeah, which is good.
It's a really
Yeah, it cuts down on cosmetics changes and stuff, and LabVIEW's well known for that. So you end up with you change one file and all these files change and you don't know why, and especially with the without separating compiled code, it gets really bad. But
Yes.
yeah, that is one of my wishes too, and a good auto formatter. I think Jim Kring is working on some stuff that might make that easier. The other thing too, you were at GDevCon. Weeby gave a presentation, and I haven't seen it, but it sounds like that might also be useful. Something about searching LabVIEW for graphs and stuff.
Yes, there's actually there's plenty of interesting stuff in his presentation. One thing is for differentiating, but also for searching. So basically, what he builds, if hugely oversimplifying the huge amount of work he did, but you could search for the caller of your VI. So basically, it would branch out in the tree and find which the caller of your caller was. Yeah. So that's quite interesting, and also it had access to all other properties of a VI. So if you wanted to find all the ones without separated compile code, of course you can do that from the project today. But if you're looking at a specific set of VIs, that could be very interesting to see, and it could also search for values within an enum. With and filter all your results based on either of the criteria that you could come up with in the VI server. So it's really, really powerful and really, really nice looking. So definitely give that a look when the videos come out. And if you have time, then take a look at mine by 15 minutes of icon discussions, which is also hopefully fun.
Yeah, no, I have a Weeby on now. So
cool.
Very good. All right. Thank you very much, Jesper.
You're very welcome. Thank you for giving me the opportunity, Sam.
Thanks. All right, cool. We can stop recording now. That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram @TheLVExperiment.